Oh, hi there. Thanks so much for showing up for your learning. It's Mr. Jennings, and we are looking today at what's in our video today, Mr. Jennings. We're looking at a Delta Math walkthrough where I'm going to walk through all the skills for you. I'm going to also introduce this idea of volume of cylinders and prisms, cones and pyramids tomorrow, if I'm there. And I'm also going to do a speed run of all the skills. If you can finish the Delta Math in 10 times my time or less, you're doing pretty good. Okay, but first, most of the mistakes that you're going to make today are going to have to do with rounding numbers. So I want to make sure you know how to round numbers correctly. Okay, here's a question that you might be asked in Delta Math, and that is like, we've got this circle here. It happens to be 8 centimeters in diameter. And Delta Math won't give you 8 centimeter circles, they'll give you 8-inch circles because circles are bigger in the United States. And we've been asked for the circumference of the circle to the nearest 10, to the nearest unit, to the nearest tenth, all these different ways to round this number. And I'll show you also how to give an exact value if you want to amaze your friends and look like a real mathematician. Okay, so, well, engineers are real mathematicians too. So let's go here, Claire. Here's what we would do. We first find our formula for area of a circle, and I find, circumference of a circle, and so I find that the circumference is equal to pi multiplied by the diameter. So that's a pretty great formula to use. I have circumference is equal to pi multiplied by 8. And I'm just going to do that on a calculator. So let's go get the calculator, everybody. And I take pi, and I use the pi button because see all that detail that I have there? I've got pi to like the, width of a hydrogen atom relative to the circumference of the universe type level. Not quite that accurate, but pretty good. And I multiply this by 8 because that's what the formula told me to do. Okay, and then I put that over there somewhere. And now, let's say I want that to the nearest unit. That might be the basic way. I look at this and I say 25.13. 25.13 is the closest unit is 25. You see this 0.1 is less than 5, so it rounds down. It goes down to the 25. Okay? Now, if I wanted to round that to the nearest 10, on the other hand, well, 25, this 5 would round to the nearest 10. The nearest number of tens is actually 30. So this is going to be equal by rounding to 30 to the nearest 10. So that would be my quote-unquote answer there. Okay, 30, 25. Now, when we're rounding past the decimal place, which is generally where you're going to be doing it, the tenth, we want to know what that means. Okay, let me just write down this number here because I'm tired of referring to it on the calculator. 25.13274122. It's way more detail than I'll ever need in this lifetime. Okay, so there's our number. If I want to round that to the nearest tenth, these are the tens, these are the units, and then this here is the tenths. Okay, it's 1/10 of a unit, so it's 1 behind the decimal place. It's, 10 to the power negative 1. To remind you, that's 1 on 10 to the 1. That's that decimal place. Okay, and so we were around to the nearest one of those. Well, I look at this digit. I look at the first digit that I'm going to eliminate. I see that it's smaller than 5, and I round down. So this is 25.1. Pretty easy peasy. Okay. On the other hand, if I'm rounding to the nearest hundredth, over here, that would be 2 past the decimal place. So I look at this one, I see that it's less than 5, so I keep that. So this would be 25.13. To the nearest thousandth, on the other hand, all right, so to the nearest thousandth, we're really talking about getting it correct as possible with that much detail. Okay, and then I look at this decimal place and I see, oh, wait, 7. I happen to know 7 is bigger than 5. So this one goes up. Okay, so this is 25.133, not 132. All right, so that's how this do. Okay, that's how you round to several decimal places. Okay. Now another thing to note is we only ever round once. Round at the end. Round when you're giving an answer. Keep stuff like this on your calculator and keep working with that number on your calculator rather than copying down a rounded version and copying it into your calculator. Here's another strange thing that students sometimes do. It makes my face change. Okay, let's say I have this number like 2.44449. And you ask them to round to the nearest tenths. Okay? The correct answer is, if I round 2.449 to the nearest tenths, it's 2.4. Okay? Because it's very simple. You do exactly what I said, which is you look at the next digit, see that it's less than 5, and don't round up. Okay? That's all. All right? But here's the big brain thing that students will do. They'll say, well, I see that if I round here, I can get a 5. And then this 5 would round that one up, and that would be a 5. And then this 5 would round that one up, and that would be a 5. So I'm going to say this is 2.5. No, don't do that. You can't round more than once. You're rounding and then rounding and rounding and rounding and compounding your rounding error. It's a very strange, weird thing to do. This whole thing is less than 2.5, so it round down. Okay, if you were rounding to the nearest 0.5, it would be 2.5, but whatever. Follow the instructions. And don't invent weird, funky, big brain ways of doing things. No one told you to do that. You invented that. Be careful about things that you invent yourself. That being said, it's good to try things and problem solve and use your brain. Don't get me wrong. Now, if you want to give an exact answer here, the exact answer is 8 multiplied by pi, and there ain't no other way to do it, and that's actually my preference. But you can't go to the hardware store and say, can I please have 8 pi inches of wire? Like if you ask for 8 pi inches of wire, people will say, 8 pi inches? What? Like, do you mean like you're going to make a wire tin for pie? Like, are you baking? Anyway, so don't do that. Okay, so that is how to round numbers. This part of the video done. Okay, so now we're going to go to walkthroughs of all skills. You are going to want to do this practice effectively. Pencil and paper to write things down, to get your rough work good. Okay? You're going to need a calculator. You can use the one in the computer. You can use the one in Delta Math. And you're going to need Delta Math and just open mind to learn these skills. So let's go. Okay, I'm going to see if I can just open that up a little bit more so I can see the eraser. Oh, come on. There it is. It's really kind of hidden. All right, there we go. Okay, so our first skill is perimeter numerical. Okay, and so here's what I would do with a problem like this. All right. First, I'm asked to find the perimeter of this shape. So I'm going to go ahead and write down my numbers. I see I have 8 feet twice. So I would do it this way, 2 times 8. And then I have how many 4.1s? And I count them, 1, 2, 3, 4, 5, 6. I have 6 4.1s. So I would write this down, plus 6 times 4.1. And then what else types of shapes do I have? I have 2. So 2 times 2. I have 2 2s. So plus 2 times 2. Okay? Plus there's one more, 11.9. So there's 2 of them. 2 times 11.9. Okay? And so now I've got all those numbers written down, and I just crank it on a calculator, folks. I mean, you can try doing these in your head if you want like some kind of mental math workout, but who does that these days? You're looking at them. Okay, so I go 2 times 8 plus 6 times 4.1 plus 2 times 2 plus 2 times 11.9 equals 68.4. Diagram's not to scale, watch out. 68.4. Submit it. And remember this important step, everyone. Good job, pat on the back. Okay. So notice they do it exactly the same way I did, because they had it in a slightly different order. Okay. There is another way. If you want to do it this way, instead of saying 2 times 8, you can do 8 plus 8 plus 4.1 plus 4.1 plus 4.1. But why would you do this? when you can use multiplication. I've only got even 5 of them. I still need to keep going, right? So who does that? So I would suggest doing it this way. With multiplication, it's very useful. All right, so that's that skill. It's just crank a few of them and make sure that you can get it right. In the algebraic ones, on the other hand, we have these types of situations where we don't know any of the side lengths, but we can give them in terms of the variables. So I know I can look at that and I can see, well, let's count them alphabetically. So it looks like there's a bunch of C's. Oh, there's a B. Okay, there's one B plus 3 C's. 3 times C. C plus C plus C. Okay? There's one D. There's 2 E's. And there's one F. So that's what you type. Okay? B plus 3C plus D plus 2E plus F. That's all. Okay, that's what you're going to do for these, is work these ones. Anything else that we need to take a look at here? Not really. I kind of wish that they had better ones, but they don't. Anyhow, let's go. And then we get into area of triangles. Okay. All right. This one. All right. We got to use our area of a triangle formula to solve something like this. Here's what we know. We have this triangle. It looks like this. So absolutely copy out the diagrams onto your page and work with them. I do this all the time, and I'm good at math. You avoid doing this stuff, and you wonder why math's still hard. Okay. And then, so that's 2.6 high. I don't know the base, so I'm just going to... Anyone know that I have a B and D thing? I need to see it. I don't know it before I write it. Which one is a B and which one's a D. Anyway, and I've had lots of practice, so some things are slow to come, I guess. All right, so I don't know the base, but I do know that the area is equal to 7.15 centimeters squared, okay? So if area of a triangle is equal to, I check my formula sheet, the formula sheet that you have, is base times height divided by 2, okay? And I know the height is this, and I know the area is this. I put those things in the formula. 7.15 is equal to, I don't know the base. I don't know the base, so it's still just B. Multiplied by the height, 2.6, divided by 2. Okay? And now, we just solve this for B. That's all. Okay? A couple ways to do that. I'll show you what I believe the simplest way is for you. Would be to evaluate 2.6 divided by 2, because that's something you can just evaluate. This over here. All right? You can just find that on your calculator. This is how you do that. 2.6 divided by 2 equals 1.3. Oh, yes, I was faster than a calculator. Amazing. All right, so I got 7.15 equals 1.3b. And now you recall that you can just divide both sides by 1.3 to find out what that is. So I've got 7.15 divided by 1.3 equals 5.5, one of my favorite numbers. And that, friends and neighbors, is the value of the base that would give you this area. That's how you do. Okay, 5.5, enter. Yay. Okay, let's take a look at another one. We've got decimals, we've got fractions. Let's go. All right, so now we have to find the area of this triangle. So guess what my first step is? Copy out the diagram. It's a great time. And then this is 6/5 centimeters. And this is 5 on 2 centimeters. Great. I'm glad you're getting this practice. This is great practice. So we just recall our formula for area of a triangle is area is equal to base times height divided by 2. Notice I write it out every time, even though I'm not going to forget that. You're going to. So write it out every time, and then you won't forget it, just like me. Okay, and then I know this is the height and this is the base, or I can rotate my triangle and flip them, doesn't matter. All right, and then I say area is equal to, this is the base, 5 on 2 multiplied by the height, 6 on 5. all divided by 2. Okay? And then I use my fraction skills to do this. Watch this. 5 divided by 5 is 1. 6 divided by 2 is 3. So the area is 3 on 2. 3 on 2, I wonder if it will accept the fraction answer. I would naturally give this as 1.5 square centimeters, but it may like this just fine. Yeah, it likes it fine. Yeah, it did. I'm 99% sure it will take a decimal as well. Let's see. So that one is square feet. So we are 5/24ths, and that doesn't have a nice decimal. I don't want to write the decimal in. Let's do another one. 9 on 8 square meters. Okay, yeah. Anyway, so I'll do one more of these, because these you'll want to. These will be the more challenging ones that you do today. So here I know that we have this triangle here, and its area this is 3 on 2 meters. We don't know the base, but we do know area equals base times height divided by 2. We know the height and we know the area. The area is 9 on 8, and the base is b, we don't know it, and the height is 3 on 2, and we are dividing by 2. So 3 on 2 divided by 2 is 3 on 4, because you flip this and multiply. That's 2 on 1. Flip it and multiply, 3 on 4. Okay? So 9 on 8 equals 3 on 4, b. And I can tell you that b is 3 on 2 again. That's very cool, but you can't see that yet. So I'll show you what I do here. Or what you can do is you just multiply by 4 on 3, both sides. You take this fraction and flip it, if you recall. So I multiply this by 4 on 3, and then I get some these cancellations on this side. Cancel, 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 cancel. b equals, on this side, we go cancel, cancel, that's a 2. Cancel, cancel, that's a 3. What did I tell you? It's 3 on 2. Okay, so 3 on 2. This happens to be the same answer we put in before. I just wanted to test for you and make sure that I can, if I want, put in the decimal answer. 3 on 2 is 1.5. It takes it just fine. Okay, so those are really good. And yeah, we got 5 of them to give you lots of practice of those skills. Now for some ASMR, me pouring my morning coffee. I hope you enjoyed that half as much as I did, because then you really enjoyed it. Okay, let's go. Now we got some composite shapes. Oh, I love me some composite shapes. Okay, we want the shaded area of this rectangle. 2 ways we can approach it. You could do it this. I'll show you both, and they're the same. But you think they're different. But I know they're the same. Because they're the same. All right, anyway. First step is the same in both cases. Is copy out the diagram. Oh, he's so sick. Oh, my son is so sick. This is 3. This is 10. This is 6. Okay. So now we've got this here, and we want the area of that. All right. The first way is to do it as a composite shape, and this is probably the way I would choose to do it, because I don't memorize a lot of formulas. So what I do is I say this is like the shaded area is equal to the area of the big rectangle minus the area of the triangle. Okay, here is like the big rectangle, you can see it here, big rectangle, everybody. And then the triangle this is a right angle, so it's a right angle triangle, that's very handy. This is 3 high there, because 3 plus 3 would be 6 on the other side, both sides are the same. Okay, and it has base 10. Okay, so if I do this, the area of the rectangle is length times width, and the area of the triangle is base times height divided by 2. So the shaded area can be given by length is 10 multiplied by 6, okay, minus the base of my triangle is 10, the height of my triangle is 3, and I have to divide it by 2. Okay, so then that will give me 60 minus 30 on 2, minus 15. Okay, so this is the number 15. Your calculator will tell you so, unless you mistype the number. Okay, and then that is, or unless I'm making a grave error and I have to remember to put another one on the board when I get back. 15, so for 45, it's 45. So, yeah, so that's one way to get the answer. Want to see the other way? Of course you do. Of course you want it. That's why you're here. To see all the ways of doing these wonderful problems. Method number 2 is to just say that the shaded area is a trapezoid, and the formula for area of a trapezoid is A plus B divided by 2 multiplied by the height of the trapezoid. Okay? You average the two parallel sides. Okay? This side and this side happen to be parallel. All right? And you find the average of those two. You basically are taking this and kicking it up there so that you make a rectangle. And this side length here would be the average of this and this. Anyhow, so we use this, okay? A plus B have to be the parallel sides, in other words, and we saw a lot of errors with that yesterday. Okay, so the shaded area is equal to 3 plus 6 divided by 2 multiplied by the height, which is 10. Okay, so now we're going to do 3 plus 6 first, and then divide it by 2. So surface area is equal to 9 on 2 times 10, and surface shaded area is equal to 4.5 times 10, and shaded area is equal to 45. Do you believe me yet that really the two methods are the same thing? They're just different. It's like saying, oh, you walk to school on that street? I walk on the street right next to it. You're still making the same number of like east, west, north, south moves. It's just the same. So here, 45, you still go to school. Yay! Okay, new one? Yeah, I want one with a circle in it. Shape of a rectangle. Square units. Oh, the shape of a rectangle. Yeah, so what's the shaded area? Well, it's half. It's 3. Okay, because it's half of the rectangle. And the cool thing like that you can see here with this example is you see that little shaded bit that my cursor is over and this little open bit? You could rotate that in your mind down here and it would fit it perfectly. And then this chunk up here would fit down here. So 3. Yay, okay. I want one with the circle in it. Oh, wait. No, we just have trapezoids and triangles. That's later. I have you doing that later. My apologies. Now we get to this one. Okay, so the radius of a circle is 7.8. We want the circumference to the nearest whole number. 2 ways to approach this one. They both involve writing a diagram. So do that on your whiteboard or on your paper or just somewhere, please. Please draw lots of diagrams. See, this is how you diagram a circle. You draw your best circle. You know the radius, so put the center on the circle and draw the radius. This will save you errors and pain and suffering. 7.8 is the radius. 2 options now. One is to work with this formula. Circumference equals 2 pi r. That's one of your options. So you just plug and chug. C equals 2 times pi times 7.8. And that happens to be, oh gosh, 15.6 pi. 7.8 is 15.6. But 7.8 times 2 is 15.6. Okay. So now we go 15.6. Well, let's actually 7.8 times 2 equals times pi equals 49.0088. Wait. They want it to the nearest whole number, to the nearest units is the nearest whole number. So that be 49. Yay. Okay. Here's the other way. The other way is to remember that the radius is half the diameter. So we can improve our diagram by doing this, saying here's the diameter of the circle and that's 15.6. And we can work with this formula that C equals pi d. And when you say these two formulas are different, I say no, they're the same. To me, that's exactly the same formula. If you know what I mean. 2 times r is d, it equals d, so it's the same, it's not different. It's the math thinking. Okay, so, and we'll get to the same place. It's still this. So that's that. Given radius, given diameter, yeah, we've got just those two types. And then area of a circle. So area of a circle. We use a different formula for area than circumference, okay? Ask Carson Jones about the cases where area equals circumference. He and I have discussed that at length. He'll be happy to have that conversation again with you. We're not having that conversation right now. We're just going to do these questions. So here. First step is draw a diagram. Can you believe it? First step is always the same, so easy. Okay. 13 meters is the diameter. I draw the diameter. Oh, wait, I only have this formula. Area of a circle is equal to pi multiplied by the radius squared. Man, it gave me diameter and I need the radius. So here's what I do. I go 13 divided by 2 equals the radius, because diameter divided by 2 equals radius, because this from the center out is the radius there, 6.5. Okay, 13 divided by 2 is 6.5. So I do 6.5 squared, which I don't happen to have memorized, and I could work it out, but I don't want to, so I'm going to do that and go squared. And there it is, and then I do that multiplied by pi, and I say equal. So that was 42.25 pi was what my calculator told me. And then that's the number. And we want it to the nearest tenth. So that's 132.7. The 3 after the 7 disappears and rounds down. 132.7. I think I copied that right. Be very careful here. You don't want to make that error. Yes, it's good. Submit answer. Is it good? Come on now. Come on. Oh no. One, 132.7. Yay. All right, so that's how that one do. And then we're given diameter, given radius. Given radius is easier. You don't have to calculate the diameter. So you could, oh, oops. Yes, back. Oh no, okay. One moment, everybody. I will find it again. It's gone. I need to go in here. Find this. And we're back. Okay. So area of a circle, rounded. Area of regular shapes. All right, that's what we want. Okay. All right, cool. All right, team. Now, if we got these area of irregular shapes questions, we are asked to find the area of this composed of a rectangle and 2 semicircles, round to the nearest tenth place. Okay, cool. Nearest tenth place. Guess what the first step is, everybody? Copy it down. It looks a little bit like a hockey rink or something. Maybe like a curling rink, or I don't know what. Maybe like a cross section of a pill, like some kind of pill. Anyway, this is 6 across there, and it's 10 from end to end. And we want total area equals area of the rectangle plus 2 multiplied by the area of the half circles. You can also notice that this shape plus that shape makes a whole circle. One circle. Okay, so rather than do that, let's say this is equal to the area of the rectangle plus the area of the circle. Okay, because that's an easier way to calculate. You don't have to divide by 2 and then multiply by 2. And I would also tell you it's the same. Okay, so area of the rectangle is length times width plus area of the circle is pi r squared. And we get these values from up here. The length and the width of the rectangle is 10 and 6, so 10 times 6 plus the radius here, well, it's half of 6. So the radius of my circle is 3, so that's pi times 3 squared And then the exact value of this area would be 60 plus 9 pi. 3 squared. Remember, I still am talking to people. This is 3 squared. Does that mean I multiply by 2? No. When we multiply by 2, this is how you write down multiply this thing by 2, please. 3 times 2. Or I would maybe write that 3 times 2, okay? Like that. Those are multiply. 3 squared is 3 times 3. It's 2 copies of 3 multiplying. This is a recipe saying please multiply by that many copies of that thing. It's different, so we have a different way of writing it down. Okay, so that's the exact value. And then if I want to convert that to a decimal approximation, I use my calculator. 60 plus, and I do it in Benjamin order, plus 9 multiplied by pi equals 88.27. And we want it to the nearest tenths, so that's going to be 88.3. Okay, 88.3, because the 7 past the 2 makes it round up. 88.3. Submit. Yay! Okay, so that's a good one. Let's see, rectangles with 2 semicircles. This is all these, I hope you get to try all of them. Square with 4 semicircles. That sounds fun. Isosceles trapezoid with a semicircle. Love it. Okay, so here we go. There's an isosceles trapezoid and 1 semicircle. So what the heck is an isosceles trapezoid? Well, we looked at isosceles triangles, and you're human beings that can extend your learning. So I suspect that you can still figure this out. So here's what you do. You copy the diagram first. Oh my gosh, he copies a lot of diagrams, guys. He copies all these diagrams. Oh, I've also noticed he's good at math. Maybe we should be copying our diagrams too. There. So this is 2. This is height 4. And this is 10. Isosceles trapezoid just means these 2 sides are the same. We don't even need that for this question. It's fine to not have that information for this question. But it's nice to know. And the more you know, rainbow. Okay, so let's go. We have all we need. So the total area is equal to the area of the trapezoid plus the area of the semicircle. Or maybe you write this in an even more beautiful way. You say this is 1/2 of the area of the circle. I like that better. Okay, so now I go in here and I say area of the trapezoid. Well, that's a plus b divided by 2 multiplied by h plus pi r squared divided by 2, because we're dividing by 2 here, because we have half the circle. Put in your values. A plus b, that happens to be 10 plus 2. Okay, that's, remember, these have to be the parallel sides. Have to. 4, that's fine. Yeah, works. 10 plus 2 divided by 2 multiplied by the height, which is 4. Okay, see the height there, 4. And then pi r squared. If the diameter of the circle is 2, then its radius is 1. It's half of that. So this is pi, this is still plus pi times 1 squared divided by 2. This is equal to 12 divided by 2 is 6 times 4 plus pi on 2, because 1 squared is 1, so that's 1 pi divided by 2. And that gives us 24 plus half pi. Pi is half off today. This is this holiday special. So, oh, we need this rounded to the nearest tenths. Well, this is a job for a calculator man. Actually, I can kind of do that in my head. It's 20 to the nearest tenths. It's going to be 25.6, isn't it? I don't know. Don't hold me to that. Oh, geez. 1 second. Plus pi divided by 2 equals that 25.6. What is that? 25.6. Okay. 25.6. Oh, how did I do that rounding, Mr. Jennings? Okay, so we are asked for the nearest tenths place, and 25.57. Seventh is the hundredths place. We're planning on dropping that hundredths place, but we still need to round up. So we're going to be 25.6. Oh man, it did this thing again. See if it takes it this time. No, so you got to refresh. Yeah. Anyway, it's true. Okay. All right. Let's keep going. Okay. So that's irregular shapes. One moment. And we're back. All right. So let's go. We're going to do volume of rectangular prisms now. I only want you to do one, but this is an interesting exercise and it helps you think of volume in a visual way. This is something that I'm doing and I'm good at math, so you want to do these things too. I don't know how good I am at math, but I tend to be better than most of my students. So let's go. First, answer all the questions below. Okay, we want to determine the volume of this rectangular prism. Let's say I know nothing about it. Okay, boop, 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 boop. Oh, I can see that we can stack little cubes up there, and I count them. 8. There's 8 cubes in there. Okay, cool. 8. Enter. Try. Yes, it liked it. And then press the play button. Okay, sure, I'm ready to play. Boop. Doot, 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 doot. Well, that's 10 columns of 8. Oh, yeah, that'd be like 80, right? 80. Try. Yeah, it liked it. Okay. And now what I want to do next. Okay, 80. Okay. Oh, wow. Each one is like a sheet. Oh, wow. There'd be 9 sheets. Each sheet would be 80. So that's kind of like what we did was like, it's a little bit like this. We did 10 times 8 times 9. Okay, because that was like 80 in one of those sheets, and there were 9 such sheets, so that'd be 720. Yay! Yay. Okay, so that's how you do those. All right, and then you get into just do a couple. Okay, a rectangular prism has a length of 18, a height of 3, and a width of 4. So the way you answer these is you get some blank paper, and I've run out of blank paper. This is good. I'm going to get some more out. I've got an infinite amount after all. So, first thing, you won't believe what the first step is. You'll be like so amazed. I can't believe it that he does this. Okay, so we have a length of 18. Oh man. Okay, a length of 18 meters, a height of 3 meters. Okay, so it's going to be like this rectangular face staring at us, and a width, I'm going to do that kind of like depth, of 4. Okay, so I draw these pictures. If you can draw them in your mental whiteboard, draw them on your mental whiteboard. Practice seeing them. It's really useful. And if you can't, draw them on paper. Very useful. Okay, so we got 18 times 3 times 4. What? Why am I struggling with this? It's 48. 48 times 4 happens to be... Is it 192? I think. 3 times 4 times 18 equals... Oh, wow. I really biffed that. Okay, so that's 216. So then you do that. Okay, so 216. 216. Yep, yep. Yay. Okay, and then some other types given cube edge length. So we can have cubes too as well in these problems. So suppose I have a cube with an edge length of 13. Oh man, we were looking at this yesterday and I don't remember what 13 cubed is. So this is 13 and they're all the same. Okay, this is a cube that I'm drawing for us. So that's the same as that is the same as that. They're all the same length. So these little ticks say all of these edges are the same and that's a right angle. So it's 13 times 13 times 13. Here's how you can do these on your calculator. There. 13 cubed, 2197. 2197 is 13 cubed. I'm trying to remember it because this may come up again. It came up yesterday and it's coming up today. It's 2197. So that's good. So that's how you do those. Next, we have volume of prisms. All right. Prisms and cylinders. Okay, we've got these two different, so we're going to be given base area and height. Okay. All right. So various different situations. Okay, and here's the thing about prisms, prisms and cones, and prisms and cylinders, things that are called regular shapes. Okay, so we're going to do the regular 3D figures. Okay, suppose I have a square, like some kind of chocolate bar like shape that's shaped in a square. It's holidays, so I'm thinking about all the chocolate that I'm going to eat. Where this is the same as that, we'll call those 2, and that's 2, and then this is 10 long. Okay, so if we want to find the volume, that's like that animation we saw where we fill up the rectangular prism. This is a rectangular prism. And basically all we're doing when we find the volume of shapes like this is say find the area of this face that where if I chop this, like let's say I chop it there, I would have like inside there the same face. Like if I cut the chocolate bar, it makes the same shape all the way through. That's what it means to be regular. It's like if I chop it with a knife or a CAT scan or a laser cutter, it would be the same shape. It would make like a deli slicer. Okay, it's lots of different ways. Okay, so there's that. So the area of that is constant throughout the length, and the volume of regular figures is always area of the base multiplied by the depth. Like this is the depth dimension. Okay, so in this case, the area of the base is 2 times 2. It's a square, and the depth is 10. You're working your way into the video, Sickle? Feeling okay? Just got that terrible cough. It's a tough day in the Jennings household. So this is we're blessed. We're lucky to be able to be sick and hang out together. 40, so that would be 40. Okay, but it doesn't matter what the shape is. We could have a weird, like, let's say a duck shape. Okay, so I'm going to say that this is, well, maybe a duck is too hard to draw. Maybe it's a oval. Okay, so I have this like new chocolate bar that I'm bringing to market, and it is an oval with a smiley face on it. Okay, and then this has a depth like that, and it goes back to this oval end. And anywhere I chop it, it's going to be an oval. Okay. If I tell you that the surface area of that is 10 and the depth is 22, it's a very big chocolate bar. It's 22 centimeters. It's got like about like that big around. It's like a tube of chocolate. You want one of these in your stocking. Okay. So then to find the volume, that would be equal to the surface area of the base times the depth, and that would give you 10 times 22 is 220. These are centimeters, if I wasn't clear before. Centimeters cubed. That was centimeters squared, to be honest, surface area. So, and we measure volume in cubic centimeters. That was what you were seeing on that little animation there. Okay, so there's that. And that's how we do these. So, armed with that knowledge, it's tough, eh? Hold on. So in cases like this, where we know the base has an area 32 units squared, right? I can just copy this out. Pyong, 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 pyong. And it goes back to this shape back here. And it's going to look something like that. All right, and then I know that this is 32 units squared, and it has a depth of 4. I just do 32 times 4 equals, why is this hard? 128. Yeah, so its volume is 128. So just do that in calculator. Your calculator tells you 32. Okay, oh, so I don't know what 32 times 4 is, so I use my calculator. Sometimes I think I confuse people because I just jump over and they don't know where I'm getting these numbers. I'm getting them because I do the calculation. And you can do the calculation on a calculator, that's fine. Or you can get a little more practice and find ways to do them mentally and fall in love with math like me. Okay, so that's like that type. So if I know this, okay, let's say I know that this pentagonal prism has a base area of 25 units and a volume of 325 units. So with these, again, copy out the shape. It's fun to do your pictures. All right, and it looks like this. It's a 3D shape. I'm not going to do all the dotty stuff there. And this is 25 units on this face, and we don't know the depth or its height. They're saying height, okay? I'll call it height, fine, height. But I do know that the volume is equal to, well, surface area of the base multiplied by the height. But I'm told the volume. It's 325, and that's equal to 25 times the height. Oh, how will I do this? Oh, right. Yes. If I'm multiplying my height, I want to find the height. My goal is like h equals, what is the height? Happens to be 13. We're going to get there 13, but we divide both sides by 25 because division is the opposite of multiplication. So 25 divided by 25 is 1. We are left with height isolated over there, and then your calculator comes in handy here because you go 325. Or you type in what's on your whiteboard. 325 divided by 25 equals 13. There you go. And it's 13 units. That's how this one do. Okay. And if we have height and volume, find the base area. Okay, so this one here. This triangular prism below has a height of 11.1 units and a volume of, wow, I'm gonna need a diagram here, folks. So I copy it out as best I can. All right, I know that it has a height of 11.1 and a volume is equal to 5.3 units cubed. Okay, and I want to know the surface area of the face. So I copy out my formula. Volume is equal to the surface area of the base multiplied by the depth or height, whatever they're saying height, so I should have said height. Depth, height, same. If I stand it up, it's height. If it was depth, who cares? Okay, so now substitute into your formula. Okay, volume is equal to 255.3. Surface area is, I don't know that yet, but I sure would like to, and height is 11.1. What's the opposite of multiply by 11.1, everybody? Divide by 11.1 is the opposite of multiply by it. So we divide both sides by 11.1. That looks like a fun little problem to do in your head for those that want to do that, but I'm just going to go 255.3 divided by 11. I think it was, what is it, 24? No, 20. 23 is 23. There we go, 23. Okay. 23. Yay! So that's how you do these. Any questions? Hit me up by email. Okay. Cylinders. Volume of cylinders. Okay. Cylinders work the same way as these other shapes. Just like I was showing you with like the weird smiley face chocolate bar. I'm out of pages again? Oh man, I went fast. Oh no, I've got pages up here. All right. So cylinder has a, copy out a diagram, everybody. A cylinder has a base diameter of 6 centimeters. So draw this. 6, there's its diameter. A height is my beautiful cylinder of 5. What is the volume in cubic centimeters to the nearest tenths place? Oh, we get to use so many of our skills here. So, volume of a cylinder, you will find this on your EQAO formula sheet. It is pi r squared h. It is the same as what we were just looking at. Surface area of the base multiplied by the height. Okay, it's the same. So we're just going to use that. All right, let's go. And then we're just going to substitute in. Oh, wait, though. Wait a minute. We don't have radius. We have diameter. That's the radius, r. And this is the diameter, d. And radius is half the diameter. So the radius is 3, folks. So we have the volume is equal to pi times 3 squared. That's just putting it in for radius. And then times the height, which is 5. Okay, so the volume is equal to pi times 9 times 5. The volume is equal to 45. That's 9 times 5 pi. That's the exact volume. Now we're going to go ahead and approximate that with our calculator. 45 times pi equals 141.37. We want it to the nearest tenth, so that's 414.4. Okay, the 3 rounds up because the 7 is bigger than 5, so it rounds up. So this is 141.4 centimeters. Go, there we go. Boom. Yeah. So those are all the skills. Okay, those are all the skills for today. Any questions, hit me up by email. I also did promise you a speed run, but I don't know if I have an appetite for that because this guy here needs some attention. So I will do one. I'll tell you my time. You can record your time, how long it takes you to finish all these questions, and see if you can beat 10 times my time. Okay, if it takes me 7 minutes and it takes you 70, I think you're doing pretty good. Okay, so any questions, hit me up by email. Otherwise, bye for now, everybody.